Hi everybody, and welcome to exercise 6 on page 21 of the workbook. Let's read this question together. They'd like us to write the polynomial x plus 5 in P of R as a linear combination of the polynomials x plus 2 and x plus 6. Okay, now let's remind ourselves what this notation P of R represents. So that's the set of all polynomials with real coefficients. And so linear combination, again, what that's really asking us kind of conceptually is, can we build the polynomial x plus 5 as a combination of these other two? Okay, so doing that would mean writing x plus 5 as a times the first polynomial plus b times the second polynomial. Okay, and asking, can we find numbers a and b that make that a true statement? Well, let's play with the right-hand side a little bit. If we multiply that out, we get ax plus 2a plus bx plus 6b. And we can reorganize that right-hand side by grouping. So we group the x terms together, we get a plus b times x, and then the constant terms look like 2a plus 6b. Okay, so what is that telling us then? Well, we need the left and the right-hand sides of the equation to agree with each other. So if we go over to the left and remind ourselves there's kind of an imaginary 1 in front of that x, we need that 1 in front of the x to match this a plus b. That's the way those two polynomials are going to be equal. Okay, and then we also need 5 to equal 2a plus 6b. So it's two equations that we're looking at. Let's write both of those down. So a plus b has to equal 1, and 2a plus 6b has to equal 5. Okay, we can go ahead and write that in matrix form. Okay, or if you prefer, you could just leave it in a-b form and just solve the system of equations that way. Either way is okay. Okay, and notice that the first non-zero entry in the first row is our 1. We'd like to get a 0 below that. Okay, and I think we can do that if we take negative 2 times the first row, add it to the second row. Okay, so if we leave the first row the same, okay, and do that, we'll get negative 2 times 1 is negative 2 plus 2 is 0. Then negative 2 plus 6 is 4. Negative 2 plus 5 is 3. Okay, and we wind up with a system that looks like this. That's an echelon form. Okay, there's our two pivot positions that I circled. We've got zeros below those. Okay, so let's see if we can solve the system that we came up with. So starting with the second equation, that reads 4b equals 3. Okay, if we take that and solve it for b, we're going to get b equals 3/4. Okay. And going up to the first equation, if we read that off, that looks like a plus b equals 1. Okay, if we substitute the b in that we already found, that would say that a plus 3/4 is equal to 1. Okay, and if we then take that and solve it for a, we're going to get a is 1 minus 3/4, which is just 1/4. Okay, so we have figured out what a and b have to equal, and so we should be able to write down our linear combination. So the x plus 5 that we started with, okay, looking back at the left-hand side of this equation, is going to be a, which we now know is a fourth, times the first polynomial, plus b, which is 3/4, times the second polynomial. Okay, there's our linear combination. Okay, maybe just one last comment here. When you do a problem like this, you can always check your answer. Okay, do you see how you might do that? If you take the right-hand side and just simplify that, multiply the 1/4 and the 3/4 through, add everything up, and what you should get, if you've done everything right, is the left-hand side, the x plus 5. That's just kind of a nice handy way to check yourself.